Good morning, everyone. This is Amit Kumar Singh, and welcome back to yet another session on quantitative aptitude. Today, in this session, I'll cover a topic which is very important for more or less every competitive exams which we talked about. Either it's related to management, or it's related to engineering, or it related to any government jobs related exams. So more or less, this topic which you can see in your screen is logarithm, and logarithm as a topic is very important. You can expect one or two questions in every exam, probably which can come from this concept of algebra, and it is one of the very important topics. So talking about logarithm, although many people consider logarithm as one of the very important and very difficult topic, but you have to understand the exams which we are talking about here. Their calculators are not allowed, and because calculators are not allowed in some exam nowadays, they gives you online calculator. So in those exams, when they expect you to solve questions on logarithm, so they are not actually expecting you to solve question based on log and anti-log table, what we have done in our schooling time. If you remember, CBSE and ICCA board in class 9th, we used to have this chapter called logarithm. So there, when we studied logarithm, so there the idea of studying logarithm was to understand the concept as a mode of calculation. So when John Napier, around 17th century, when John Napier came up with the concept of logarithm, there at that time calculator were not so much pronounced. So that time people were using logarithm as a medium of calculation. But nowadays when we see logarithm as a topic, so more or less when I talk about logarithm, I see logarithm to as a concept which can simplify my calculation. Imagine if I want to find this value called 2 to the power n is equal to 5. Suppose I want to find this value. So suppose whenever I'm performing mathematical operation and I want to know the value of unknown, and if that unknown is in power, then the best way of solving this question without using calculator and all would be to use the concept of logarithm. So how logarithm help us nowadays? Because if you multiply the log with both sides, so if you multiply the log with both sides, so log of 2 to the power n is equal to log 5. So if you multiply log with both sides, so ultimately what will happen? Log is the inverse function of exponential. So what happens if you multiply log? If you multiply log to the power 2 to the power n, so what will happen? This n will come in this form. So ultimately this will become n log 2 is equal to log 5. So ultimately the value of n would be log 5 by log 2. So this would be your value of n. So this way, if we solve the question like this way, then it become very convenient for us to get the answer of this n. Now those who know the basic on log, say they know this value called log 2 is equal to 0.3010. So when I talk about log 5, so log 5 is nothing but log of 10 divided by 2. So I can say log 5 is nothing but it is log 10 minus log 2. So if I want the find the value of log 5, so this would be 1 minus 0.3010. So that will give you the answer called 0.699. So if I want the value of n, so the n value is nothing but 0.699 divided by 0.3010, and that will give me the value of n. Okay, so I hope you can understand what I'm talking about here. So the idea is that whenever we are working, on log, probably for competitive exam, so the idea is to understand how we can use these application of log to solve the question. So the idea is to use these applications to solve the questions where the questions will not be based on the tables or computation of the values. The question will be based on the idea that how much you can understand the concept of logarithm. So imagine if I would have asked you 2 plus n equal to 5, what is the value of n? 2 minus n equal to 5, 2 into n equal to 5, 2 divided by n equal to 5. So if I would have asked you those values, you could have easily solved it. But the problem happens if you have to determine the unknown, and if that unknown is in power. So how will you identify the value of that unknown? So there the concept of logarithm comes in the modern world mathematical application. The same thing we use in compound interest problems also when we are solving problems on aptitude. So more or less we have to, if you are working on some kind of compound interest calculation, there you have to determine n, and there again the n would be in power if you remember the formula of compound interest and all. So there the application of logarithm comes in picture. So although after the introduction of logarithm in around 1614, if I remember correctly, then the logarithm started being used in many applications on physics, in medicine, and probably in other discoveries, other mathematical calculation. If you remember chemistry, this chapter called chemical kinetics, if I remember. So there we use log. Again in calculus also we use. So that there probably we see lot of application of logarithm. Normally here when you see this calculation, whenever you write log, you always write log in the base. There's a base is there when you work on log. Always the log is written with base. That is a very unique thing in log. We always write the log with base. When base is not visible, we believe that the base is 10. We believe that the base is 10. That is called common log. Generally we express log in two form. Either when we express log, when we are studying log, in the expression of log, either the base of log is either 10, that is called common logarithm. Either the base is 10, that is called common logarithm, or your base is either e, that is called natural logarithm. That is called natural logarithm. Okay, so that is called natural logarithm. Okay, the relation between common logarithm and natural logarithm is log base e is equal to, it is around 2.303 of log 10. That is the relation you can remember. Okay, so I hope you all are preparing right now for government exams or management exams. So you definitely would have studied logarithm in your schooling level and all. When I'm doing this recording, I'm assuming that all the listeners who are listening to me, they have basic knowledge of log and all. So you all know that log 10 log 10 base 10 is 1. Everyone knows that part. So you can easily calculate that also. You can check with calculator this value. Imagine just if I use Excel just to prove you this. So so you know that when I'm writing log, this is log 10. So this, sorry. So if I'm writing log, so if I'm writing log of 10, so I'm getting the value 1. You know the reason why. And if similarly, if I write log e of 10, so you can see 2.303. So this is the relation what I told you. So the relation of log e and log 10, you can easily understand that part. Okay, so you can keep this in your mind. Well, base can be anything in log, but that should be positive number, not equal to 1. But normally, while expressing that logarithm, you can use two forms of bases more prominently. Either it's base 10 or either it is base e. And when you talk about e is the Euler number. Leonhard Euler came up with this concept. He found very interesting constant, that is irrational number. So he found very strange relationship. So if you sit with Excel or any calculator, if you write that y equal to 1 plus 1 by x to the power x, and you put any value of x here, so ultimately you will get a constant. That constant is somewhere, there's an irrational number. It is 2.70. It is 2.7. It is 2.71828. Sorry, this is around 2.71828, like this constant you will get. So that was put under the name of this mathematician called Leonhard Euler, and this is called as E. So that is, if you use Excel and all, there E we write with exp. So we write with exp. So you can see 2.71828. Okay, so this is basically is your E. So I hope you have understood somewhat basic knowledge on logarithm. So although we see logarithm as difficult topic, but we need to understand there are some laws are there. They logarithm chapters, when you solve the problems for logarithm, you solve the questions based on certain laws. It is an inverse form of exponential of mathematicians what you have studied till now. So if you have fair knowledge about these laws of logarithm, you can easily solve the questions on logarithm. Solving questions on logarithm is not at all difficult thing. Every exam, even in exam like cat and all, you can expect one or two questions definitely on logarithm. So that way you can understand how much this chapter logarithm ultimately become important for you. So when I ask you this value, Carl, like I told you, you can remember few things like log 2 is 0.3010. You can remember log 3 is equal to 0.4771. So when I'm writing this value, here I'm writing these values with base 10. Okay. So all you can see I'm not right. Base is not visible here. So here I'm assuming that the base is 10 only. Okay, so if you remember this, you can easily find the value of log 5. So log 5 would be nothing but log of 10 divided by 2. Okay, so log of a by b is nothing but log of a minus log of b. So if you do this, log of 10 base 10, that will give you 1 minus 0.3010. So if I ask you what is the value of log 5, so the value of log 5 is 0.699. So if you know the value of log 5, you can easily find the value of log 125, 625, all that. If you know the value of log 2, you can easily find the value of, if you know the value of log 2, you can easily find the value of log 4, log 8, log 16, log 128, log 256, all that. If you know the value of log 2 and log 3, you can tell me the value of log 6. Okay. For those who have basic knowledge on log, they can easily tell me what is the value of log 6. So log 6 is nothing but log of 2 into 3. So that is nothing but log of 2 plus log of 3. So that will give you the value of log 6. So log 8, log 9, you can easily find log 12. All these values, if I'm asking you what is the value of log 12. So if I'm asking you what is the value of log 12, so log 12 is nothing but log of 2 square into 3. So the value of log 12 is nothing but 2 log 2 plus log 3. That will give you the value of log 12. You know what is log 2, you know what is log 3. So you can easily get this value. So while many of you would be understanding how I'm solving this, many people can easily understand what I'm talking about here. Many people would be still finding it difficult. Those who would have forgotten the basic concept on logarithm, what they have studied in their schooling, so they may find it not so much interesting. Anyway, maths is not at all a interesting topic, and then that too, if you study something like logarithm, which follows a different unique ways of solving the question in different ways only. It is altogether, it's a logarithm is altogether, it is a revolution in the way we do calculation. So when we work on logarithm, we follow a different set of benchmarks while solving the problem. So let's try to understand logarithm as a frame that as if we don't know anything about logarithm. So imagine now the class has started. Imagine that whatever I have told you till now, you can just assume that you skipped it or you just erase that from your memory. So whatever I've taught you till now in logarithm, you can erase that from your part of your memory. Now, basically, if I talk about logarithm, so imagine if you write this number like 10 to the power 3 is equal to 1000. Suppose if you wrote it like this, then if you're writing it like this, 10 to the power 3 equal to 1000. So if I ask you how can you express this in logarithm, so you'll write the same thing as log base 10,000 is equal to 3. This is the way how you express the number in the form of logarithm. So when you write this number in the form of logarithm, then this 10 is called the base. Then this 10 is called the base. This 1000 is called as the argument. Okay, and this 3 is the power. This 3 is the power. So when we express the number, whenever we have a number, and if we are expressing a number like if suppose a to the power x a to the power x is equal to y. Suppose there's number written like a to the power x equal to y. So what is basically logarithm? So logarithm of a given number to a given base is the index of the power to which the base must be raised in order to get the given number. That is basically logarithm. So the same number, if you want to write in the form of log, so how you write in the form of log? You write log base a y equal to x. So when you write the number in the form of log, you have to remember few things, that you can never find the log of negative number. So when you're finding log, you have to keep few things in your mind. You can never find the log of a negative number. The base, what is there in logarithm, it should be positive number not equal to 1. So how to express this in the form of logarithm? So here, conditions for logarithm, condition for solving in logarithm, condition for solving the problem in logarithm. So your condition should be, your y should be greater than 0, your a should be greater than 0, and your a should not be equal to 1. So whenever we write the number in the form of logarithm, your base and your argument both should be positive number, and at the same time your base should be positive number not equal to 1. So you have to keep that in your mind. Many people would be wondering what is the problem with 1. So what is the problem with 1? So you can easily understand this. So now if I write the log, suppose the base is 1, this is like a. So ultimately you can express this number in this form, log of a by log of 1. So if the number is log a base 1, so you can write that number as log a by log 1. Okay. So now what is log 1? If you have basic knowledge on log, you can tell me that log 1 is equal to 0. So any number divided by 0 is what? Is cannot be defined, not defined. So it is not defined. So that's why the base on logarithm can never be, it can never be a 1. Okay, now log 1, why log 1 is 0? So why log 1 is 0? So you have to understand this part. Suppose the base is b, base is b. So why log base b 1 is equal to 0? Because you have to understand the concept on logarithm, that the concept of logarithm is basically to what extent the base should be raised, to what power the base should be raised, so that you can get the argument. So it means what power of b will give you 1. So you have to tell me what power of b will give you 1. And if you know the basic law of exponential, you can easily tell me what power of b will give you 1. That power of b would be 0. Okay, so the fair knowledge, if you have this much, it's, I hope that is more or less is convenient. So if I'm plotting the graph of y equal to a to the power x, if I'm plotting the graph of y is equal to a to the power x, so your graph is something like this. So your graph would be something like this, where if you put the value of x, if you put the value of x 0, if you put the value of x 0, then y would be 1. So x 0, y 1. Where here the condition is that a should be greater than 1. A should be greater than 1. So if your a is greater than 1, ultimately your graph would be like this. Okay. So this is basically because log, when we talk about log is the inverse of exponential. So we should know the graph of exponential also. So if you know, it would be good for us. If I talk about y is equal to a to the power x, and if your a is between 0 to 1, if your a is between 0 to 1, then the same graph would be like this. Then the same graph would be like this, where this would be 0 comma 1. So this would be the graph if your a is between 0 to 1. So exponent graphs are very important to understand log. So when we work on log, it is important. It would be good if we can understand the component on the basis of exponential. So when we talk about exponential functions, like suppose there's exponential function. Suppose there is an exponential function. Suppose there is an exponential function. So suppose there's an exponential function. Suppose there is an exponential function called e to the power x. You know what is e? E is the Euler number. So if you write exponential function called e to the power x, that will give you e to the power 0 plus e to the power 1 by 1 plus e square by 2 factorial plus e cube by 3 factorial plus e to the power 4 by 4 factorial. So many time in interview also they ask you the formula of e. So this way also you can express in e. So here you can write e to the power x is nothing but it is a summation of n tend to the 0 to infinity, uh, where this is, it is nothing but e to the power n by n factorial. So this way you can understand logarithm. Whenever you talk about logarithm, how you can write, how you can express this in the form of log. Sorry, here not e. I wrote everything in the term of e only. So this, you can introduce another variable called x. So 1 plus x plus x square by 2 plus 2 factorial, then x cube by 3 factorial plus x4 by 4 factorial till infinity. So this you can write as n to the 0 to infinity, where this is nothing but x to the power n by n factorial. So this exponential form, what we have studied here. So the inverse of this exponential form only will give you the value of logarithm. The inverse of this exponential form only will give you the value of logarithm. Like if you remember that basic things, the first thing what I told you, like you can remember log 2 is equal to 0.3010. So when you see this value, then if I ask you what is the value of log 20, so the value of log 20 is 1.3010. If I ask you what is the value of log 200, that is 2.3010. So whenever you find log value, log always give you approximate value. Two argument can never give you the same value of log. You have to understand this part. Now when you find the log, whenever you find the log of any argument, any number, whenever you're finding the log of any number, you get an integer part and a decimal part. So whenever you find the log of any number, whenever you're finding the log of any number, whenever you're finding the log of any number, so the answer what you get, that log value what you get, so the log value what you're getting, it will have two components. One would be your integer part, one would be your integer part, one would be your integer part, and the other would be your decimal part. So whenever you find the log of any number, the one would be your integer part and the other one would be your decimal part. So this integer part what you get, this is called as characteristic. This is called as characteristic, and the integer decimal part what you will get, that is called as mantissa. The decimal part what you will get, that is called mantissa. To get this decimal part or mantissa, we use log table. Okay, so to get this mantissa we need log table. Okay, so but log table will not be given in any exam. Okay, I'm talking about competitive exams. So log table will not be given in any competitive exam. So in case if there's any question which requires the application of log, what they will do, they will give you the value of mantissa in the question only. Okay, so you don't have to worry on that part. Only thing you have to learn here for the preparation of competitive exam is to understand how to calculate the characteristic. To find the characteristic, to find to find the characteristic, what you need to do, you need to count the number of digits before decimal. So count the number of digits before decimal on the left hand side of decimal. So whenever you see any number for which you want to find the log, whenever you see any number for which you want to find the log, you need the characteristic value. How to get that characteristic value? Count the number of digits. Count the number of digits before decimal on left hand side of decimal. Count the number of digits. So then the characteristic would be one less than the total number of digit in the left of the decimal point of the given number. So how many numbers are there here? Left of decimal, only one number. So 1 minus 1, 0. So you can see characteristic is 0. Here the digits are 2. 2 minus 1 is 1. That's why your characteristic is 1. Here the digits are 3. 3 minus 1, 2. That's why you see the characteristic is 2. If I ask you what is log, of like something like this, so what would be the characteristic? The decimal would be still 0.3010. So how to find the characteristic? Count the digit. 1, 2, 3, 4, 5, 6, 7. 7 minus 1, 6. This is the answer. So this would be a characteristic. This is easy. When you give a number greater than 1, confusion arises when I give you the number less than 1. So if I give you the number less than 1, then what you need to do, then you have to count the number of zeros between the decimal point and the first significant digit of the number. So you have to count, like when I'm giving you a number less than 1, then what you have to do, then if I suppose something like this, let me give you example 0.457, or why to write 0.57, better write 2 only. So suppose 0.2 or 0.002 or 0.000003 something like that. So what you have to do, you have to count the number of digits, you have to count the number of zeros. Whenever you get the number less than 1, what you have to do, you have to count the number of zeros. You have to count the number of zeros between the decimal and the first significant digit of the number. So how many zeros are here? How many zeros are there? How many zeros are here? How many zeros are here? How many zeros are here? No zero. Here 2 0. Here 1, 2, 3, 4, 5 0. So to count the number of zeros between the decimal and the first significant digit. Okay, and then whatever the value you get, add 1 to that. Whatever the value you get, add 1 to that, and negative of that would be your answer. So here the characteristic would be 1 over bar 0.3010. Here the characteristic would be 3 over bar 0.3010. Here the characteristic would be 6 over bar 0.3010. So you have to understand, you have to understand the difference between this and this. If I'm writing like this, suppose I'm writing 3 over bar 0.3010, what that means? That means minus 3 plus 0.3010. This is the number. If you are writing, if the log of some value, you will get this value called 3 over bar 0.3010. It is nothing but it is minus 3 plus 0.3010. If you want to write this in complete negative value, so what you can do, you can do minus 3 minus 1 plus 1 minus 3 minus 1, then you can do plus 1, then minus 3, 1 minute. So if you want to write this minus 3 minus 1 minus 1, okay, so minus 3 minus 1, okay, so this way you can write the number like this way. So this is okay. So ultimately you can express this number like this form. Ultimately this is 3 over bar 0.3010. But suppose if you see a number something like this, maybe minus 3.3010, then your number is actually minus 3 minus of 0.3010. Now if you want to express this number in this form, so you can write minus 3 minus 1 plus 1 minus 0.3010. Ultimately you'll get minus 4 plus of 0.699. Ultimately you can write this number as 4 over bar 699. Okay, so the same number, the same number you can write the same number as 4 over bar 0.699. Okay, I hope you understood this. So this way we can work on log. Whenever we work on log, so the calculation of characteristic is something which is important for you to understand. Otherwise, Mentisa and all are not so much relevant for you to calculate. Okay, so suppose if I ask you some questions. Suppose if I ask you some question like this question number 1. So how will you solve question number 1? So to solve this question number 1, we need to understand the laws on logarithm. So we need to understand the laws on logarithm. So when we talk about the laws on logarithm, we should be aware about the certain laws on logarithm. So we'll talk about uh, those laws of logarithm, or those who knows the value, they can easily tell me the value of this is not what, this value is minus 3 by 2. So they can easily tell me this value. This value is minus 3 by 2. This value is 4. This value is 2. You do, those who understand log, for them, those who know the laws on logarithm, they can solve this question very easily. They can tell me the answer very fast. Others can think. Others can think on that part how they can solve this question. So now I am giving you some time. Think on this part questions. How will you solve this? Like question number 3, 4, and all. How to solve these questions? Just a kind of quick revision. For those people who don't know, for them it is, for them they can think on that part how they can solve these questions. And those who knows the laws on logarithm, for them it could be kind of consideration for them to think about this part, how to get this value. Think on this. I'm giving you 2 minutes time. I think by this time you would have came up with the answer of question number third and all. So the third one, if I talk about the answer, so this, I think the third one, the answer would be 0. If I think the correctly, the third one answer, the answer for third one would be 0. So if you have any other opinion, you can tell me the third one answer. Okay, the fourth one would be 729 square. This one would be 729 square. How to find the square of the number? You can watch my Vedic maths video on how to find the square of the number. So we'll discuss these questions. So I need some more time to discuss this question. Let me give you more knowledge about this Christectic and Mentisa. So I hope you would have understood the concept on Christectic and Mentisa. So the point on which you need to give emphasis here is to work on the calculation of Christectic. Mentisa calculation is not at all much important for you. So if you have a basic knowledge on characteristic and mantissa, so based on that I can plot the graph of y equal to log of base ax, where if a is greater than if a is greater than 1, if a is greater than 1, then your graph would be if you take you know that whenever you find the value of log, whenever you find the value of log, you know this very well. Whenever you find the value of log, you know that that whenever you're finding the value of log, you know that very well, that log, you cannot find the value of log for negative number. So when you talk about the x value of log, when you talk about the x value of log, or if you talk about the domain of log, it should be only the positive value of x. It can't be negative value of x. When you talk about domain of log of e to the power x, the domain should be the positive value of x. It can't be negative value of x, should be always be positive value of x. So the x should be all the positive real number. If the x on log, it should be all the positive real number. So that then that would be the value of x. Okay, so here when if you plot the graph, so if you take any number which is between 0 to 1, if you take any number between 0 to 1, you will get a negative value of log for that. And at the value 1, if you take x value 1, so you know that you'll get the value of y equal to 0, and then your graph would be like this. So this would be the value, this would be the graph of log of base ax if a is greater than 0. So all positive value of x, if you take any value greater than 1, you will get the y positive value of y. And if you take any x value which is between 0 to 1, then you will get the negative value of 1. So that when you talk about the range, when you talk about the range of log of ax, that would be from minus infinity to plus infinity. When you talk about domain of log, it would be only the positive value of x. It would be between 0 to infinity. So you can talk about on you can talk about domain and range also. So similarly, if you plot the graph, if you plot the graph of this is 1 comma 0. So if you plot the graph of y equal to log base ax, and if your a is between 0 to 1, if your a is between 0 to 1, so you'll get the graph like this, where this value you'll get, this x value you'll get if your x is between 0 to 1, and all the values of x which is more than 1, you'll get the negative value of y for that. So you can remember the graph also. So it's very important. This graph on logarithm and all is very important. We use logarithm when we talk about calculus, even in the concept on finance and all, derivatives concept and all, where there the log is used in much more important way. So you know about normal distribution, you know about normal distribution in statistics. In finance, we talk about log normal distribution. Log become very important when you study some variable, and if that variable is very volatile, then the concept on log and all will become much more relevant or become much more important there. So these principles on log again is very important whenever we work on log. So graphs also, it is important to understand everything in the context on graphs. Now next important thing if I can talk about is that if I want to find the logarithm of any number, if the base of that number is a, if I want to find the logarithm of any number, if the base is a, I told you whenever you work on logarithm, I told you that whenever you find the logarithm of any number, if the base is a, or if suppose you write y equal to log base ax, I told you that your x should be greater than 0, a should be greater than 0, and your a should not be equal to 1. So imagine if I ask you some questions like just for your practice, the condition for logarithm. If I want to understand the condition of logarithm for some number if I want to study understand their conditions of satisfying the concept of logarithm. Suppose if I ask you this question like log of base x and x minus 1. So tell me the values of x which satisfy this equation log base x, x minus 1. To solve this question, if I want to solve this question, if I want to solve this question, so if I want to solve this question, I know that x should be positive, x should be, if I look at the base, then x should be greater than 0, and then x should not be equal to 1. And if I see the argument, then x minus 1 should be more than 0. It means x should be greater than 1. So what I can understand, if I plot a number line, this is 0, this is 0, this is 1, this is 2, like this is minus 1, minus 2, like this. So if I see the x should be greater than 0, so if I see the x should be greater than 0, okay, the x should be greater than 0, okay, then the x should not be 1, x should not be 1, x should be greater than 0, and x should not be 1, and x should be greater than 1, and x should be greater than 1. So what is the argument which is intersection of all? So the argument which is intersection of all would be your x should be greater than 1. The x should be greater than 0, and x should be greater than 1, and x should not be 1. So what is the concept which is the intersection of all? So with that you can say that x should be greater than 1. Similarly, just for your practice I'm just doing. So similarly, if I ask you another question, suppose I ask you another question, suppose log of base x minus 1, and this is the argument is x minus 3. Tell me what values of x will satisfy this equation. So for that I can say that x minus 3 should be greater than 0. So it means x should be greater than 3. That is condition number 1, that your x should be greater than 3. Next thing, x minus 1 should be greater than 0. It means the x should be greater than 1. Okay, this is the next condition, x should be greater than 1. Third thing is x minus 1 should not be equal to 1. It means the value of x should not be equal to 2. So what that means? It means that if you see the number line, if you see the number line, if you see the number line here, the value of x should be greater than 1. It should be greater than 3. It should not be 3. So here I can say again the value of x should be greater than 3. So the condition which satisfy all is that the x should be greater than 3. So this basic knowledge also if we have, then it will be more than enough for us to solve the questions and all. So that then it would be more than enough for us. Solving question won't be a very big thing. Okay, so now going further, if I talk about the property on log and all, if I talk about the properties on log, if I talk about the properties on log, so imagine you want to find the logarithm to any base. If we want to find, if we want to find, we want to find, you want to find logarithm, if you want to find the logarithm to any base, to any base, if you want to find the logarithm to any base, suppose the base is a and it gives the characteristic, and suppose it gives the, suppose if it gives you the characteristic, suppose it will give you the characteristic call n, and suppose if you give you the characteristic call n, okay, suppose if you give you the characteristic call n, then the number of then the number of then the number of possible then the number of possible integral then the number of possible integral values then the number of possible integral values will be it will be a to the power n plus 1 minus a to the power n. So the number of values which can satisfy this would be a to the power n plus 1 minus a to the power n. So you can remember this concept. So if you are working on log and suppose in that log your base is e and your characteristic is n, so the number of possible integral value of which can satisfy this condition that would be a to the power n plus 1 minus a to the power n. So suppose for example, suppose you want to find the log of base 10x. Suppose there's a number log x where the base is 10 and you got the answer called n point a b c d, something like this. So here the base is 10 and the characteristic is n. So the number of integral values, then it means the number of integral values which gives you the answer. So the number of integral values would be 10 to the power n plus 1 minus 10 to the power n. So this would be your answer. So imagine suppose for your better understanding, if I say log of base 10 x gives you 2 point a b c d. This a b c d is the Mantisa. Mantisa is not relevant for me. Suppose the base is 10 and log x and the characteristic is 2. Characteristic is 2. You can understand that log base 10. Characteristic is 2. You can easily understand log 100 give you the characteristic 2. The small, if the base is 10, the smallest possible value of the number which give you the characteristic 2 is 100. Okay, so 102 it will go till where? Till 999. I hope you remember 100 to 999. If you remember, guys, correctly. Okay, how will you get the characteristic 10? What is the formula for positive number, for any positive number greater than 1? What I told you the formula for any positive number greater than 1. What I told you the formula, count the number of digits. Count the number of digits before the decimal. The characteristic is 1 less than the total number of digits before decimal. Imagine if you're getting characteristic 2 and the base is 10. So everyone can tell me your number will start from 100 to 999. So that value, if you want to calculate like this mathematically, you can. So the formula for that would be number of integral values. Your number of your integral values. Your number of your integral values would be 10 to the power 3 minus 10 to the power 2. So that then it would be 1000 minus 100. Then this would be 900. This would be from 100 to 999. So you can count the number of terms from 100 to 999. So you can, if you want to count, you can follow the concept of AP and all. You can count this. Okay, so I hope you can easily do this. So n is equal to 900. So the same thing, if I ask you, imagine if the characteristic is 3, then it would be from 1000 to 99999. So then that value you can count it. So that would be 9000. So you can, I hope you can easily understand this part. Okay, so that would be very easy. Can we understand? Similarly, if you find the characteristic of any number 10 to the log x where the base is 10, and if your characteristic is negative, then it means the number of 0 between the decimal and the first significant digit would be n minus 1, because you know the inverse. I'm talking about inverse. Of the same thing. So imagine if you finding log of base 10x is equal to minus 3 point abcd. Okay, so you know the characteristic is minus 3. You know that here the characteristic is minus 3. How you get the characteristic minus 3? I hope you can easily understand. How you get the characteristic minus 3? You get the characteristic minus 3 because the number of zeros were 2. Because if you remember the formula, it's the inverse of what we have studied. Very basic, very simple. So I hope you can easily understand what I'm talking about here. So the number of zeros between the decimal and the first significant digit, then that would be the 2 zeros. Very simple concept. It's the inverse of whatever we have discussed. It's the inverse of simply the same thing. So let's talk about the properties of logarithm. So let's talk about the properties of logarithm. Let's talk about the properties of logarithm. So all the problems, all the questions on logarithm, whatever we'll solve on these properties only. So the basic properties of logarithm, whatever you can study, is log of base AB B, base is A and this is number B. So you can write this as log of base can be anything, divide by log of base can be anything A. You can write the same thing as 1 divided by log of base B A. Okay. Then the next property of logarithm you can remember, log of base can be anything, log of 1 will always give you 0. Whenever you want to find the log of 1, the 1 is always 0. The third thing you can understand, if you number, if you base and the argument both are same, then the value would be 1. Okay. Then the fourth thing in logarithm you can understand, log of base anything, mn, so then it will get log of m plus log of n. If you remember when I asked you what is log 6, when I asked you what is log 6, so I told you log 6 is nothing but log 2 plus log 3. So this is the way how I got. When I asked you log 6 was log 6. When I asked you log 6, when I asked you log 6, the log 6 was nothing but log of 2 into 3. So that is nothing but log of 2 plus log of 3. You know the value of log 2 and 3. Similarly, log of base A m divided by n. Then you will get log of base A m minus log of base A n. Okay, simple. Then when I talk about log, suppose log of, suppose you want the p to the power q and this is a to the power p. The base is a to the power p and number is p to the power q. So then the value this would be q by b is equal to log base a b. Okay, so you have to understand this. So how to understand this? You can understand this with this formula, that log of maybe log of this question, log of this question only. So log of 36 1 by 216. So suppose log of 36 1 by 216. Suppose you want to solve this question. You can write this question as log of 1 by 216 divided by log of 36. Okay, so you can write this number as log of 216 is nothing but 6 to the power minus 3 and 36 is nothing but 6 to the power 2. Ultimately, this will give you the value called minus 3 by 2 log of 6 by log of 6. Then you'll get the answer called minus 3 by 2. So very important thing, if you remember, I started the class with that only. So that log of a to the power m will give you m log a. Base can be anything, doesn't matter what is the base. The log of a to the power m will give you m log a. So this is a very basic thing. I believe everyone knows this concept. This log of 8 is nothing but 3 log 2. That everyone is aware about that part. Okay. So the next concept, property number 7 is a log base b c. A log base b c is nothing but c log base b a. So lot of questions in exam come from this concept. So that way this concept become very important for you. So I can show you some question based on that. Some question based on that. You can see this question. So if you see this question, suppose if I copy this question, now you can see this question. So suppose find the value of, if you want to solve this question, find the value of b to the power 2 5 log base b 5x. So if I want to solve this question, so what can I do? I can write this question as b square, it's log base b here. So can I write this number as x to the power 5? So you can understand this. Okay, now going further, what can I do? I can write this number as x to the power 5 log base b square. And I can change the power. Now ultimately, you know this will give you what? ultimately, this will give you what? So if you solve only this part, if you solve only this much part, if you see this much part, so ultimately you can tell me this value. This is nothing but x to the power 5. This will be 2 log b. That will give you 1, and everyone can understand. This will give you what? This will give you x to the power 10. And a log base b will be 1. And then ultimately what left? Log, sorry, x to the power 5 to the power 2. Ultimately, you know that it will give you x to the power 10. Clear, right? So this is again important for you. You can understand this. So I have discussed more or less all the properties on log. I have discussed more or less all the properties on log. Imagine if I ask you this. Suppose if I ask you this a log base ax is equal to what? So you can write this number as x log base a. So that will give you x. So that way you can easily understand. Now suppose if log base a b is equal to x. Now suppose if log base a b is equal to x, where your a is greater than 0, a is not equal to 1, and b is greater than 0. Okay, so remember this. So then remember log of base 1 by a will give you minus x. Okay, you can easily understand this. So then log of base a 1 by b will give you minus x. Okay, same logic. And you can say then log of base 1 by a and your argument is 1 by b will give you x. So you can understand this part. Okay, so if I want to discuss this, log of base 1 by a b, if I want to discuss this, so you can write this log of b to the power 1, and here you can write this a to the power minus 1 as a base. You can write 1 divided by minus 1 will give you log base ab. That will give you minus log base ab. So hope you remember that property. So here we studied one property. So we studied this property. The same thing I'm applying here while solving this question. Okay, so this is important thing. You keep this in your mind. So while solving the questions, we use these properties. It will be helpful for us to solve the question based on these properties. Anyone have any doubt? Anyone want to ask anything? Please write in the chat box. Sorry, please write in the chat box, or you can write in the comments also. When the class get ended, you watch the session. In case if you have any doubt, you can write in the comment box your concern or your feedback, whatever you feel. You are most welcome to do that. We are living in a democratic country, and that too we are studying a subject like mathematics. So then it's very important that we should have a rights to speak about whatever we are feeling while going through the learning process of learning mathematics, and that to the concept of mathematics, which is logarithm, which is very painful exercise. So that I can understand. So, but even then, it is important because if you want to clear any competitive exams, then it becomes significant for us to do that. So, if I talk about question number 2 and all, question number 2, So question number 2, log this running in packet anyway. One, so anyway I've done. Question number 2, if I talk about question number 2, if I want to solve question number 2, you can write the question number 2 like this. So this is log base 2, this is log base 3, 81 you can write 3 to the power 4. So then you'll get log base 2, it will give you 4 log base 3, 3. Ultimately log base 3, 3 is 1. So this you get log base 2, 4. Ultimately you can write this log base 2, 2 square. Then you got the answer. Simple. So third one also you can solve it like that way. Third one also you can solve like that way. So imagine I'm just copying this question. So now I want to solve this question. So how to solve this question? You can see this. So just you can see this. This is 125. 125 to the power cube is nothing but 5q to the power cube. So this would be 5 to the power 9. So now this is log base 5 and this is 5 to the power 9. So what it will give you? It will give you log base 2, log base 2, then log base 3, and it will give you 9. Okay, now 9 means 3 square. So you'll get log base 2, that is 3 square. So you'll get 2. So now log 2 means you'll get 1. Log base 2, 1 is equal to 0. Simple. So question number 4 is simple. Again, you can write 81 as 3 to the power 4. So you can write 81 as 3 to the power 4. So then ultimately what you will get? Ultimately you will get is 27 to the power 4. What is 27 to the power 4? 27 square 729. This is 729 square. Find 729 square. You can do that work. So 729 square, you can write 729 as 700 plus 29 square. So you can watch my video on Vedic maths if you want 729 square. 29 square is 841. So write 418 carry. So then it would be 729 plus 729. So you get 758, 9980, 4 plus 1, 1058 into 7 because it is 700. So this is 56, 5 carry, 35, 44 carry, means 5306 plus 8 means 5314. 531441. This is 729 square. You can check this. 729 square. So 531441. 531441. You can watch my video on Vedic maths how to find the square. You can write the same 729 square. You can write same 729 square as 750 minus 20. 750 minus how much? 30. 30 matlab 30 matlab sorry, 30. 20 minus 21. So minus 21 square also if you do 441. 4 carry, then 700 18, no? 729 minus 21. Sorry, not 718, that is 708. So 729 minus 21, that is 708 into 750. 750 is how many times of 100? 7.5 times. 7.5 times means 15 by 2. You can write this as how much? 354. 354 into 15. How much? 354 into 15. What is 354 into 15? So how much you'll get this? 20, 27 to carry 1770. Then this is 453. This is 0, 1, 12, 13, 5. 5310. 5310 plus 4. 5314441. Same answer what you got here. So you can watch my video on Vedic maths on how to find the square of a number if you want. If you really want to know about this squaring technique, there's one more technique is there. 729 square. This is a. This, then you follow a square, 2ab and b square. So this is also one more technique. All that I have covered in my Vedic math session. So you can watch there to understand it much more better. Okay. So coming back to the question, so now doing this question, now let's see if I can copy this. 1 minute. Suppose you want to solve this question. Now you suppose you want to solve this question, very simple. So you just need to express this number 3. This is 3, then log 81. 81 is nothing but 3 to the power 4. 80 is 16 5s are 16 matlab 2 to the power 4 into 5 plus 5 log 25. 25 means 5 square. 24 is 8 into 3, then plus 7, then log of 16. 16 means 2 to the power 4. 15 is 3 into 5. Ultimately then you apply the formula. Log of a by b is log a minus log b, and log of a to the power n is n log a. If you apply that concept, ultimately you'll get 4 log 3, 4 log 3 minus 4 log 2 minus log 5, then 5, then it is 2 log 5, it is 2 log 5 minus 3 log 2 minus log 3, then plus 7, it is 4 log 2 minus log 3 minus log 5. So you can write this as 12 log 3, 12 log 3 minus 12 log 2 minus 3 log 5, then plus 10 log 5 minus 15 log 2 minus 5 log 3, then plus 28 log 2 minus 7 log 3 minus 7 log 5. You can write this further. Log 3, focus on log 3, 12, 12, then 7, and then 7. So log 3 will get cancelled. Then log 5, 7, 7, 7, 7 will get cancelled. Now focus on log 2 minus 12 minus 15 minus 27 plus 28. The answer is log 2. This is the answer. Normally in exam, options will be given to you. So you can see the options and you'll get the answer very easily. So here I just solved the question without options, and I have not given options also in the question. I don't think it would be any problematic thing for you. The idea is that you should learn the concept. you should work on how to get the answer for the question. Okay. That is what we are looking for. Now question number 6. So these all questions, I try to pick those questions which I feel that I started with some easy questions, and then I felt that some questions which need more attention or which won't be little bit unconventional while when we see the question first time, I try to give preference to those questions. Suppose this is 5 to the power x. So this is 5 to the power x. So 5 to the power x is equal to 1000. So, or I can write 5 to the power y is equal to 1000. So I can write 5 to the power x is equal to 10 to the power 3. So I can write 5 is equal to 10 to the power 3 by x. Then I can write at 0.5. Sorry, 0.5 means 5 into 10 to the power minus 1 to the power y is equal to 10 to the power 3. So then this is 5 to the power y into 10 to the power minus y equal to 10 to the power 3. So this is 5. In place of 5, I can write 10 to the power 3 by x into y is equal to 10 to the power 3 by 10 to the power minus y. This is 10 to the power 3y by x is equal to 10 to the power 3 plus y. So ultimately, I can say that 3y by x is equal to 3 plus y. So I can say 3y is equal to 3x plus xy. So, so what I can do, so if I write 3 together, so y minus x is equal to xy. Okay, so I can write y minus x by xy is equal to 1 by 3. So this is nothing but 1 by x minus 1 by y. That is 1 by 3. This is what we are looking for in this question. Very easy. You can see these steps. So it's very simple. It should not be the question on log. It's better should be the question on exponential. So it would have been better if I would have done this question in chapter of exponential. So it's not actually the question on log. It's actually the question on exponential. You can pause, you can write down the question, you can pause for a moment, and you can see the steps. First you try to solve the question from your end. In case if you could not able to do that, then you can see the steps. Otherwise these are not at all difficult. Now see the next question. Every question you can pause and you can try to solve it. In case if you could not able to solve it, then only you can see the solution. This question, see this question. Now try to solve this question. Now if you see this question, in this question what they're asking you to find this value log of, they're asking you to find this value called log of x plus 2y. They're asking you to find this value, and what value they've given you, they've given you x square plus 4y square. So if you can find out the relation and all, you can easily understand their relation and all. This is nothing but this is given to you equal to 12xy. If you compare this with this, if you compare with this x plus 2y, and this is x square plus 4y square. So if you compare this with them, you can understand this. This is like, so this is like something, this is x square plus this is 2y whole square. You can compare this with that. Now the problem is that if you write that x square plus 4y square, if you write them in this form, that x square plus 2y square is equal to 12xy is equal to 12xy, it does not satisfy anything. It will not give you any kind of what do you say, confidence or motivation to go to the next step. What do you do after this? I write like this, what will happen? What will happen? Where this question will proceed after this? If I write this, oh, what I can do with this? Nothing I can do after this. So I need to understand. Ultimately, if this is written in the form of a square plus b square. So if this a square plus b square is equal to anything, something k, what that will give you? It does not give you anything. So it does not give you anything. A square plus b square is equal to c. It does not give you anything. So if you write any number in this form called a square plus b square, if you write anything in the form called a square plus b square, it should be supported with 2ab. Then only it will give you a plus b ka whole square. Otherwise, it does not mean anything. So imagine if I write this number as x square plus 2y square plus what I need 2ab. What is a? A is x. What is b? B is 2y is equal to 12xy plus 4xy. If I do this, then ultimately I'll get x plus 2y whole square is equal to 16xy. So I'll get this. Now if I multiply log with both sides, so I can get 2 log of x plus 2y is equal to log of 16xy. Ultimately I can write 2 log of x plus 2y is equal to, if I break this, so I'll get this log of 16 plus log of x plus log of y. So I can write this number as 2 log of x plus 2y is equal to, this would be 4 log 2 plus log of x plus log of y. So ultimately this can give me the answer called log of x plus 2y is equal to 4 log 2 plus log of x plus log of y divided by 2. This will give you this answer. If you see the options and all in exam, you can see the options. The question like this can give you different ways, different answer for the same question. Means I hope you can understand. So the same thing I can express these options in many different ways. Ultimately, when you see the options, I believe you can easily get the answer based on what you see in the options. You can get the answer based on that parameter. Doing that, I don't think would be any big homework for you to do that. Clear this. So you can see the steps. Any moment on time, if you find any difficulty, you can pause the video, you can see the steps and all, and you can reconfirm on whatever is being discussed. Now next question. So it's very good question. Log of 10 1 degree plus 2 degree till log of 10 89 degree. So to do that, the basic concept of trigonometry and all is important for us. So I believe everyone knows that tan theta is equal to cot 90 minus theta. Everyone knows this. Now going further, I can write log of 10 1 degree plus log of 10 2 degree plus log of 10 3 degree till log of 10 89 degree. So you can write this log of 10 1 degree plus log of 10 89 degree, this plus log of 10 degree plus log of 10 88 degree. Like this you can go further and you can write log of 10 suppose 44 degree plus log of 10 plus log of 10 46 degree. ultimately what will left plus log of 1045 degree will be left. Okay. So you can write this further. So you know that log a plus log b is log ab. So I can write this as log a plus log b is log ab. This is nothing but log 10 of 1 degree into 10 of 89 degree plus this is log of 10 of 2 degree into 10 of 88 degree plus similarly log of 10 of 44 degree into 10 of 46 degree plus log of 1045 degree anyway is 1, 1045 degree anyway is 1. Okay, everyone I believe know trigonometry, basics on trigonometry is more than enough, and you know that 1089 degree is nothing but, so when I talk about 1089 degree, so it is nothing but cot 1 degree. Okay, so this is log of 10 2 degree, so 1088 degree is nothing but cot 2 degree. Similarly, log of 1044 degree into cot of 44 degree plus log 1. What is log 1? 0. Okay, and everyone knows this now. So tan theta is 1 by cot theta. Everyone knows this basic trigonometry. So this and this will get cancelled, all will get cancelled. So you'll get log of 1 plus log of 1 plus log of 1 till everything will get log of 1, everything will be 0. 0 plus 0 plus 0 will give you 0 only. And 1 degree into cot 1 degree will be 1 only. So cot theta, you can write 1 by 10 theta. So cot 1 degree is nothing but 1 by 10 degree. So 10 degree divided by 10 degree would be 1 only. Log 1 plus log 1 would be log 0, 0 plus anything, 0 plus 0 plus 0, anything would be 0 only. Hmm. Now try this question. Whenever you get the question, you can pause the question for that moment. You can think on that question, how to solve that question for that moment, and then I believe you can get the answer. Once you get the answer, you can confirm your answer with my answer. So that will serve the objective, I believe. The idea here is to just to come up with some questions which can help you to develop the concept on logarithm. More or less, we have knowledge on logarithm. The only thing is that more practice will do something other way of solving the questions. All that we can learn. That is the agenda. That is the overall perspective of how we see the questions. Now try these questions, everyone. Everyone, please try this question. Now see this question, how to do this question. Now suppose this is your question. Again the same kind of steps. You can notice the same kind of steps. So this is nothing but this is a square minus 2ab plus b square. So what this will give you? This will give you a square minus 2ab plus b square. It will give you a minus b whole square. This will give you. This is nothing but this is a minus 1. This will give you what? This will give you x square minus y square into 2a minus 2, and that is equal to, this is equal to x minus y to the power 2a into x plus y to the power minus 2. So you can break this a square minus b square as a minus b into a plus b. So you can write this as x minus y into 2a minus 2 into x plus y into 2a minus 2 is x minus y into 2a into x plus y into minus 2. So this is x minus y 2a minus 2 by x minus y 2a is equal to x plus y to the power minus 2 by x plus y is equal to 2a minus 2. This will give you x minus y. This is 2a minus 2 minus 2a is equal to x plus y, that is minus 2 minus 2a plus 2. So this will give you x minus y to the power minus 2 is equal to x plus y is equal to minus 2a. So this will give you x minus y is equal to x plus y is equal to a. So if I want the value in the term of a, if I multiply log both sides, so log of x minus y is equal to a log of x plus y. If I ask you what is the value of a, the value of a is log of x minus y by log of x plus y. That is your answer. This question, I believe they ask you this only, find the value of a. They ask you find the value of a, this would be the value of a. The so these questions are not at all difficult, very simple. Step by step we will go, we'll get the answer very easily. Not at all difficult question. Only thing is little bit away from traditional. So to solve these questions, we need to use the law of exponentials also to get the answer for that. Now suppose if you see this question like this. Again you see this, again the same, see this and see this, you will understand. This is log base q, this is x square y q, this is log base q xy. You can see this here, this is xy, this is x square y cube. So I can write this number log of base q, I can write this x square y square into y, I can write like this. Okay, so then it would give me what? Log of base q. So this is a into b. So this is a into b. This is a into b means log of q y. So a into b means a plus b. So I can write this in log of base q x y plus log of q y. Okay. So this value is 3. This value is 3. This is 6 plus log of base qy, and I believe this value is given to you 4. This value is given to you 4. So the value of log base qy is equal to minus 2. You got this answer. Simple. Okay. Now what you have to find? You have to find this value. You have to find the value of log a base qx. So if you break this, you can break this log of base qx plus log of base qy. That is given to you 3, no? That is given to you 3, and you found this value as -2. Log of base qx, this is what? -2. -2 is equal to 3. So log of base qx is equal to 5. You got the answer very easily. A very easy question, not at all difficult. Only thing a little bit different in the way how we see the questions whenever we get in log. This is a little bit different to the perspective of how we see the question. Now GP and all, I believe everyone knows the concept of GP. When we talk about GP, suppose your first term, suppose your first term in GP, suppose your first term in GP is something like, what should I write, M, and your ratio, common ratio is N. Suppose your common ratio is N. So you know that N will get confused. What should I take, X or Y? X and Y. Here in this question, what term they use? PQR, ABC, PQR. Okay. So the first term is, suppose X, the common ratio is Y. So then your nth term in GP would be x y to the power n minus 1. The nth term in the GP would be x y to the power n minus 1. So ABC would be pth term, qth term, and rth term of GP. So A is the rth term in GP. So A is the rth term in GP, means x y to the r minus 1, and B is the A is the pth term, not rth term. A is the pth term. So A is the pth term, and B is the qth term, and C is the rth term. So A is the pth term of the GP. B is the qth term of the GP, and C is the rth term of the GP. Okay. And then you have to find Q minus R. Then you have to find Q minus R. Then you have to find Q minus R. Then you have to find Q minus R into log A plus R minus P plus R minus P into log B plus P minus Q plus P minus Q into log C. Okay, so I can write this as log of A to the power Q minus R plus log of B to the power R minus P plus log of C to the power P minus Q. So this is log A plus B plus C, that is log ABC, log of A to the power Q minus R into B to the power R minus P into C to the power P minus Q. You got this. Now you know that what is A. Your A is x into y to the power P minus 1. So what I can do, so I can write this in term of, in place of A, I can write x y to the power P minus 1. X y to the power P minus 1. This is Q minus R. Then B is x y to the power Q minus 1 into R minus P, and then x y to the power R minus 1 into P minus Q. Okay, so you have to find this value. So log of this would be x to the power q minus r into y to the power p minus 1 into q minus r into x to the power r minus p into y to the power q minus 1 into r minus p plus x to the power p minus q into y to the power r minus 1 into p minus q. So here if I talk about x, this is q minus r plus r minus p plus p minus q. This is your value of x. So x you can see all getting cancelled. This you are getting x to the power 0 means 1. Now if I talk about y, y is p minus 1 into q minus r plus q minus 1 into r minus p plus r minus 1 into p minus q. You see that also everything will get cancelled. So you get log of x of 10 to the power 0, y 10 to the power 0. So this you get log of 1, that will be 0. So you can spend time, you can prove that you can see this is PQ. If you notice here, you will get PQ, and this you will get this you will get PQ, and here you will get minus PQ, it will get cancelled. Then you will get minus Q, here you will get plus Q, minus plus Q, it will get cancelled. Then here you will get plus R, here you will get minus R, it will get cancelled. Everything what you will get cancelled. So ultimately the power of x and y, you will get 0 only, and any number to the power 0 is 1. So log of 1 is 0 only. So this already I have done. Now you can see this question. Think how will you solve this question? So whenever you get the terms in AP, if you should know that if A, B, C are in AP, if A, B, C are in AP, what is AP? Arithmetic progression. Arithmetic progression means the difference is same. So if A, B, C and are in AP, you should understand. Then you should directly write that if A, B, C are in AP, then you should directly write that 2B is equal to A plus C. Then you should directly write 2B equal to A plus C. If A, B, C are in AP, then the double of the middle term would be equal to A plus C, because the difference is same. B minus A will be equal to C minus B. So this way if I do, so it will be 2 of log base 3 of 2 to the power x minus 5 is equal to log base 3 2 plus log base 3 to the power x minus 7 by 2. You can write log base 3 to the power x minus 5 whole square is log base 3 2 into 2 to the power x minus 7 by 2. So log base 3 can get cancelled. So you can write 2 to the power x minus 5 whole square is 2 into 2 to the power x minus 7 by 2. So you need to solve this. So you can see LHS that is in the form of a minus b whole square. That is in the form of a minus b whole square. So if you solve that, you will get 2 to the power 2x plus 25 minus 10 into 2 to the power x is equal to 2 into 2 to the power x minus 7. So I can assume, so let 2 to the power x is equal to y. I'm just assuming that. So I can write this as y square plus 25 minus 10y equal to 2y minus 7. So this will become y square minus 12y, that is 25 plus 7, that is 32, plus 32 is equal to 0. So this is y square minus 8y minus 4y plus 32 is equal to 0. So y minus 8 minus 4y minus 8 is equal to 0. The y value you'll get is 4 and 8. So the y value you get is 4 and 8. What is y? Y is 2 to the power x. So 2 to the power x is equal to 4, and 2 to the power 4 x is equal to 8. So x value you will get, so the x value you'll get is 2 and 3. The x value what you will get is 2 and 3. In this problem, the x value what you will get is 2 and 3. Now just satisfy, just see that that 2 and 3 is possible or not. So if I think about x equal to 2, so if I put x is equal to 2 here, if I put log of base 3, 2 to the power 2 minus 5, you can see this. So the number in log can never be negative number. So 2 to the power 2 is 4, 4 minus 5 is negative. You can never find the log of negative number. So the x cannot be equal to the x equal to 3, that is possible. So this, so the here, what is the value of x? The value of x is 3. Okay, now see the next question. Now try to solve this question, guys. Everyone, please try to solve this question. Now think, how will you solve this? If I see the LHS part of this, the log of base 1 by root 2, and this is 1 by root 8. So if I focus only on LHS, so this would be log of, this would be 2 to the power root 8. So root 8 is 2 cube. So 2 to the power minus 3 by 2. 2 to the power minus 3 by 2. This will be log of root 2, that will be minus 1 by 2. Minus 1 by 2. So if you solve this, so what it you'll give, what you'll get. This is 3 by 2 minus minus will plus 1 by 2. This is log 2 by log 2. That will give you 3. Your LHS is 3. Your LHS part here, that is equal to 3. Equal to log of base 2 to the power x plus 1 plus log of base 2 to the power 4 to the power x. So 4 to the power x into sorry, 4 to the power x plus 1, I can write 4 to the power x into 4 plus 4. Okay, so this will be 3 equal to log of base 2 4 to the power x plus 1 plus, so if I take log base 2, if I take 4 common, 4 outside, 4 to the power x plus 1. So this is 3 is equal to log of base 2. And so let uh, so suppose let log base 2 4 to the power x plus 1 is equal to 2. So I can write this as 3 is equal to, so this will be t plus, so I can write this log of base 2 4 plus log of base 2 4x plus 1. So this will be 3 is equal to t plus, this will be 2 log base 2 4 is 2, 4 is 2 square plus t plus t na plus t na, so log of 4 log of, so this is a into b, no, so log of a into b, so a plus b, so this is 1 minute, so log of, okay, this is into not plus sign, so this is into not plus sign, and so this is into, this is into, this is into, so I can write this as 3 is equal to 2t plus t square. So ultimately I can write t square plus 2t minus 3 is equal to 0. 2t plus t square. So I can write this as t square plus 3t minus t minus 3 is equal to 0. So t plus 3 minus 1 t plus 3 is equal to 0. So t minus 1 into t plus 3 is equal to 0. So t value is 1 and minus 3. So the value of t is 1 and minus 3. What is t? T is log base 2 4x plus 1. The value of t, the value of t log of base 2 4 to the power x plus 1 is equal to 1. And this is log of base 2 4 to the power x plus 1 is equal to minus 3. This is 4 to the power x plus 1 is equal to 2. 4 to the power x is equal to what value? What the value? Find x. What the value of x? So I can write x log 4 is equal to log 1. Log 1 is 0. This 4 to the power x plus 1 to the power minus 3. 2 to the power minus 3 is minus, sorry, 2 to the power minus 3 is 1 by 8. So 2 to the power 3 is 1 8 and minus 3 is 1 by 8. So I can write 4 to the power x plus 1 is 1 by 8. So I can write 4 to the power x 1 by 8 minus 1. I can write 4 to the power x is equal to minus 7 by 8. Right, x log 4 is equal to log of minus 7 by 8. So you can never find the log of negative number. So here x is not defined. Here the x is not defined. The value of x I'm getting is 0. So find x. What is the value of x? X is 0 here. Then this is a simple question. Find the greatest possible value of n such that 9 to the power n is less than 10 to the power 8, and they given you the log 3 value. So 9 to the power n, 9 to the power n is less than 10 to the power 8. Multiply log with both sides. Log n log 9 is less than 8 log base 10 10. So n log 9 you can write 3 square is 8. So you can write 2n log 3 is less than 8. So you can write n. This is 2 into 0.4771 is less than 8. So n is less than 8 divided by 2 to the power 0.477. Find this value. Find this value. So n is less than 4 divided by 0.477. So 4 divided by 0.4771. So that is 4 divided by 0.4771. That is 8.38339. 8.38. So here n is less than 8.38. What they're asking you what is the greatest possible value of n. They're asking greatest possible value of n, and n is less than 8.38. So what is the greatest possible value of n? So the greatest possible value of n is 8. Simple question. Now see the next question. Try to solve this question, guys. Now you want this value, okay, and the base should be 30. If you notice, the base should be 30. Here you can see argument base is there. Base should be 30 according to you. So I can write log base 33 is equal to a, and I can write log base 35 is equal to b. So I can write log base 30 15 is equal to log a plus log b. 15 is equal to 15. If I add them, log a plus log b, log 3 plus log 5, that is log 15, that is equal to a plus b. Okay. Now 3 log base 32. So 2, I can write 3 log base 30. In place of 2, can I write 30 divided by 50? So in place of 2, can I write 30 divided by 50? Now work is done. This is 3 log base 30 minus log base 30 15. Now my work is done. So 3 1 minus ab, sorry, a plus b, that is 3 1 minus a minus b, that will give you 3 1 minus a minus b. You can see the options. Depending upon the options, you can decide your answer. Simple question. So the last question. Find the number of real solution for the equation. This is the equation. So you can pause the video to try to solve this question. Any moment of time, you can pause the video. So I can write this as 2 log base 2 log base 2x. Here if you notice, this is 1 by 2. So I can write minus log base 2 log base 2 root 2 x equal to 1. Okay, so let log base 2x, let log base 2x as t or something. Let assume log base 2x is equal to t or something. So 2 log base 2 t minus log base 2 log base 2. This is 2 root 2 is nothing but 2 to the power 5 by 2, or 1 plus 1 by 2 is 3 by 2. This is 3 by 2 x is equal to 1. So I can write log base 2 t square minus log base 2 2 to the power 3 by 2 x is equal to 1. I can take log base 2 common. If I take log base 2 common, I'll get t square divided by log base 2. Then this is 2 to the power 3 by 2 x is equal to 1. So then it means that t square, then if you open a into b, so this is log base 2 3 by 2 plus log base 2 x is equal to 2. This is t square by 3 by 2 plus t is equal to 2. This is this is this is 2t square by 3 plus 2t is equal to 2. So is equal to 2. So you can solve just linear equation, solve it. So 2t square plus 4t plus 6. So t square minus 2t plus 3 is equal to 0. Where it is. So is equal to 0. So you can t square minus 3t plus t plus 3 is equal to 0. 1 minute. T square minus sign will come. Minus sign will come here. And so minus 3t. This is t minus 3 plus 1 t minus 3 is equal to 0. So the value of t is 3 and minus 1. So the value of t you'll get is 3 and minus 1. What is t? Your t is log base 2x is equal to 3, or log base 2x is equal to minus 1. So the value of x is 8, or the value of x is 2 to the power minus 1. Means the value of x is 1 by 2. So you'll get two values of x here. One value of x is 1 by 2. The other value of x you'll get is 8. Let's just see that. 8 and 1 by 2. 8 and 1 by 2. So 1 by 2 minus 1. One minute. Number of real solution. If you see this, 1 by 2 here. 1 by 2, if you see here, log 2 log 2 log 2 1 by 2. 1 by 2 means 1 by 2 you got. 1 by 2 you got, right? 1 by 2. So 2 to the power minus 1. So if you take 2 to the power minus 1 here, you get 2 log base 2, and this would be minus 1. And you can never find the log of negative number. 1 by 2 is not satisfying the answer. So the number of real solution would be 1. There is only one real solution possible for this question, and that would be 8. Okay. Anyone have any doubt? Anyone want to ask anything? Whatever I've done. Anyone want to ask anything? You understood, right? Why 1 by 2 can't be the answer? So here the value of x, you are getting two values of x. The one value of x you are getting is 8. The another value of x you are getting is 1 by 2. But if I put 1 by 2 here, if I put 1 by 2 here, so probably then I am getting negative value of x. That's why the value of x can't be 1 by 2. It can be 8. 8 would be 3. So then 3 you're getting positive means fine. I'm not worried if I'm not getting, then I should not get negative value. If I'm getting positive value means that is okay with me. Okay, right. So I hope you have understood this. So like how many questions we have done? We have done around 18 questions in logarithm, and all the questions I explained you step by step. So you can try these questions from your own end first, and still if you have doubt when you see the steps, if you have doubt, you can go through the question again. I don't think you will face much difficulty in solving these questions. You can just see the question and try to solve the question. And once you solve the question, you can just confirm your answer with my answer. And once both are seen, then means your work is done. And you can go ahead with the next question. In case of any discrepancy, you can again solve the question and see the steps. And in case if you want to any more clarification on that part, you can please write in the chat or comment box for that clarification. That I will do from my end. So you don't have to worry from, from your end. You just need to practice as many questions as you can. So concepts on logarithm is very important for competitive exam. So with that intention, I hope you have understood whatever I've done till now. I think I've taken more than 2 hours, and in last 2 hours, I have discussed a lot of questions. I've discussed a lot of concepts on logarithm. I believe everything is clear with you people, and no one have any doubt. So keeping that faith in my mind that you have understood whatever I've covered till now. So it's time to wind up the class. So thank you everyone. God bless you.